And it is now my pleasure to introduce Mike Gualtieri, who's the Principal Analyst at Forrester. Mike, go ahead. Mike, you may be on mute. Could you check your settings one more time, please?
Sure. Hi, everyone. This is Mike Gualtieri. I'm Principal Analyst at Forrester Research, and I cover big data and advanced analytics. And today I want to talk to you about batch and streaming analytics and how, by unifying some of the elements of batch into the streaming pipeline, can lead to much faster insight and action. So first thing I want to talk to you about is some momentum that we're seeing in advanced analytics. Changing the slide here, you can see here that the use of advanced analytics is surging. We compared 2014 to 2015, and you can see I've highlighted streaming analytics with a dramatic increase in firms' current use of that technology. But you can also see predictive, text analytics, other forms of advanced analytics. You know, there's been a surge in growth. You can obviously see things like reporting is just holding steady. Now, what's interesting about this chart is that at numbers in the 40% range, that means over 50% of companies aren't using this sort of advanced analytics technology. So that's an opportunity for firms that aren't using it to get first mover advantage in using these forms of analytics. Now, when we think of analytics, you know, everyone's talking about big data, and some say that big data is the new oil. We think it's much more like the sun. It's virtually limitless. It's being created constantly. And most importantly, it's coming at us at a very fast rate. And sometimes we call this fast data. And we know that firms in all industries are interested in insights everywhere in their operations, customer insights, predictive maintenance, marketing. Every function of the business wants to put data more to work, and especially in those advanced analytics categories that we talked about, predictive and streaming. But our research shows that most firms still continue to struggle not only to find those insights, but then how do you make those insights actionable? And with things moving faster, you have to do that in real time as well. So when you think about the whole analytics that firms need, there's 4 types of analytics. There's descriptive analytics, which you can think of as traditional analytics, like business intelligence, so reporting, dashboards, and that's basically intelligence and insights done on historical data. There's predictive analytics, which is to find models in your data, predictive models, and you should think of descriptive and predictive analytics as usually batch-oriented. Okay, so there's batch jobs that run to do those reports, to find those predictive models. And then as we start moving more to the right, you'll see that streaming analytics is used to detect what's happening in real time, detect situations, threats, opportunities. And prescriptive analytics is used to determine, okay, what do we do about it? You know, we've detected a situation, now what's the best action to take? Now the streaming and the prescriptive analytics is informed by the predictive and the descriptive analytics, but descriptive and predictive are usually done, or traditionally done, in a batch mode, whereas the streaming and prescriptive are done in real time. So, just trying to switch slides here. I apologize. I can't. There it is. But doing everything in batch is insufficient because of fast data. And all data, even big data, right? It all starts out fast, but it's only often used after it becomes big data at rest. And that's what we mean by descriptive analytics that are done usually by business intelligence systems. So firms have a lot more data, transactional, usage and behavior data, social media data, sensor and event data, and increasingly data that they can buy and sell from other firms through services. But all of this data starts out as fast, right? So when there's a transaction, that transaction happens in a moment in time. Most firms store that transaction, and then the analytics takes place the day after, or it may take place a week after, right? But increasingly, firms need to understand those analytics now so they can take action. So if you think about the architecture that you need to put insights into action, it needs to be a continuous analytics to action architecture. You've got business events, situations occurring, coming in on the left side. You have to analyze those events with streaming platforms. You have to continuously learn from that information, and you have to take action immediately, and then monitor the outcome of that action so that you can revise it once again. So this is very different from a traditional BI architecture where you're taking data in and you're analyzing it, producing reports or dashboards, or even interactive discovery. Okay, this is very much using analytics and applications. There we go. So the idea behind this webinar is to give the streaming pipeline more work. Okay, so instead of attaching to the connected world, the digital world, and doing your streaming analytics, optimizing and making those decisions, and then sending the data back to, offloading it for at-rest analytics, the idea or the question is what kind of data, what type of analytics that are traditionally done in a batch mode could we bring up into the streaming data pipeline? So if you look at these, the way these pipelines work, batch processing always lags the streaming pipeline. So the streaming processing pipeline is continuous. You're taking data in from multiple sources, you're analyzing it in the moment and taking action. The batch processing pipeline lags. So the idea of unifying batch and streaming is to move some of those batch analytics to the stream so that you can gain more valuable real-time insights. So you can't necessarily move every analytical function from the batch processing pipeline, but we think that you can move a significant amount, maybe even up to, or maybe even more than 50% of analytical processing that's normally done batch can be moved to the streaming pipeline. So let me show you an example of what that might look like. So if you look at the descriptive analytics, the descriptive analytics always lags, okay, when it's in a batch process. But what if we could do that descriptive analytics and use it during the real-time processing of streaming and prescriptive analytics? So an example is an online retailer that might sell specialty motorcycle gear. And their fundamental question, how can we sell more motorcycle helmets? Maybe it's a very profitable item. So let's see how they could sell more motorcycle helmets if they unified elements of the batch and streaming pipeline. So on the left, here's typically a question that you'd be able to answer with real-time streaming. Okay, so say a user is browsing that website and you want to know in real time, when has this user viewed at least 3 motorcycle safety products or helmets, right? Because a hypothesis is if they viewed it 3 times, they're shopping for this specific product. So real-time streaming platform can be configured to easily detect that, especially in a time window. Say they viewed three products within 1 minute, and they could display the most profitable motorcycle helmets in a list on the side, right? So that's the very classic and typical real-time streaming application. But now look to the right at the real-time descriptive. What is the current daily total sales of motorcycle helmets, right? Now typically a batch process would calculate this the next day or at night. It would say, all right, what were our sales for these helmets for the day? But what if we could calculate that in real time? If we calculated the daily sales in real time, we could answer a question like this and then take an action. If the sales is trending lower than usual, then make a motorcycle helmet offer, right, to try to sell that helmet. But if sales is not trending lower than usual during the course of that day, then don't make an offer at all, get full profitability. So the idea here is that if you put this typically batch descriptive analytics in the stream, you have 100% more insights that you can use to sell more motorcycle helmets. So showing you this pipeline again, in the stream processing pipeline, on the top, customer shopping for helmets, we can detect that in real time, but we have to wait a day until we know what the sales are for that day, right? If we move that batch analytics to the stream, we gain those additional insights. So now we know when the customer shopping for helmets, and we have a real-time running total of the daily sales total. That gives us a lot more actions we can take when we detect the customer shopping for those helmets. So there's other examples that you can see how this would be valuable in the IoT world, in predictive maintenance with farm equipment. Cable companies, they record every button you press on that remote control. You can imagine batch analytics to determine what people watched. But what if you could get those analytics right now? What sort of applications could you do in terms of showing the most relevant ad? So what streaming analytics brings you is it brings you a much faster pipeline. And the way streaming analytics does this, it has to have near zero latency for even the most complex data and compute operations. So out of necessity, streaming platforms are in-memory platforms. And some of our recent survey data shows that 73% of firms are planning, implementing, or expanding the use of some form of in-memory data platform. So that could also include in-memory databases as well as streaming analytics. And if you think of the different types of in-memory platforms that are available, you've got streaming analytics, and then you've also got general purpose data processing clusters, data and compute grids, cluster databases, and scale-up databases. The streaming analytics is the only platform in this group that is designed to detect situations in real time that you need to create these type of applications. And the requirements that you need to do this in real time is you have to eliminate latency accessing data, because even if you have streaming data coming in, you often have to enrich it. You may have a customer ID, now you need that customer profile, right? So you have to store that customer profile in memory because you'll slow down the entire stream. You also have to be able to scale. Sorry about that, slides are a little out of sync. You also have to be able to scale so that you can make literally millions of these decisions at once, concurrently, and grow. So you need a scale out architecture as well. And once you start talking about streaming analytics, you're talking about something that's a critical component of an application. So it's no longer some sleepy offline analytics. It becomes a critical component, so it has to be designed to be fault tolerant as well. And it also has to fit and work seamlessly with existing architectures, because if you think about all of the streaming data is coming from other sources, other systems, and the streaming platform is doing the analytics, so it has to fit easily and nicely in other platforms. So, when you use scale-out streaming technology, it will also speed the application development process because now you don't have these architectural concerns. It's built into the platform. Scale, reliability, performance are already built into the platform. So if we look to the future of streaming analytics and how it can offload some of those batch analytics and essentially turn batch analytics into real time, analytics is something that has to happen continuously in real time in an organization. And batch processing pipelines will surrender many of their typical tasks to the streaming pipeline. The streaming pipeline is totally capable of handling it when it has a scale-out architecture. So the example I gave you with the motorcycle helmet is that of a running total. but it can also offload some ETL tasks as well. And then streaming analytics platforms are also the industrial strength glue. They become the central component for these real-time apps and analytics. So thank you very much, and now I'm going to turn it over to Jeremy. Jeremy?
Hi, this is Jeremy Johnson. I'm the Director of Product Management at Silver Spring Networks. I'm going to talk to you a little bit today about how we use batch processing and stream processing and have married the two at Silver Spring, specifically for critical infrastructure and critical infrastructure IoT applications. So first, a little bit about Silver Spring. Silver Spring Networks is a leading critical network infrastructure provider. Basically, what we do is we started off in the smart grid space, deploying smart grids throughout North America, Australia, and then the rest of the globe. We have gone from smart grids, which are typically meters and other devices on the distribution topology, into also gas and water metering, as well as street lights. And one distinction I would make about our company is that we create the technology. Not sure why the slide changed. One distinction I would make about Silver Spring is that we make the technology that connects devices. We don't make the devices themselves. So we don't actually make meters. We don't actually make streetlights, but we make the communications technologies that go inside those. We also make the software that connects them. Specifically, the software that I run at the company is called the Silverlink Data Platform. The Silverlink Data Platform is a hybrid analytics and application enablement platform. The reason that it's a hybrid is that, number one, we don't feel like there's any one company that can satisfy all the application needs for critical infrastructure IoT, and therefore it would be best for us to figure out a way to get data in, get it organized in suitable formats for various workloads, and then make that data available to other application developers. We typically think of applications in terms of three areas. There are direct-to-consumer applications, there are IT applications, so this is about the actual operation of the networks and operation of software, as well as OT applications, and this is, you know, basically the operation of the infrastructure itself. One of the big problems that we found when we started this journey was that typical architectures at a utility include a number of legacy systems organized generally around an enterprise service bus. And what this causes is it causes the prime problem in this space is actually getting data from those systems and from new devices that are being attached to those systems into a place where it can be organized and combined and analyzed. So our first step was sort of look at data ingestion and then start dealing with it in terms of real time and batch, so that we could then make it available. And what we realized is that very quickly we learned that data ingestion and real time analytics basically became the same thing, because as we're organizing data, we have to contextualize it. So for example, there are a number of alerts and events coming in from the network constantly, and there are also scheduled read events that happen throughout the day. And as that data comes in, it needs to be contextualized. It needs to be added. You know, the data itself needs to be enriched with location information, with device information, etc. And simply storing the values isn't good enough. And so that's where we turned to DataTorrent, and actually started the project with them on an enrichment process during data ingestion. And as Mike said, some of the it also handles some of the ETL functions. So as we're enriching data, we're also transforming it and loading it into our batch layer so that we can handle a number of different workloads downstream. Those include things like long-term analysis and forecasting, real-time and historic time series data, and also relational data that can be attached to BI tools so that operators can explore their data and discover new insights that maybe they weren't aware of before. Once we do all that stuff, we make the data available via a secure API layer and offer each of the operators the ability to self-service manage their data and authorize different applications to attach to that data. Thus far, we have a number of very interesting applications that range from consumer engagement, where we can do load disaggregation on energy usage. This is an interesting one where we can take a look at where we can do analysis against high-frequency meter read data and distinguish the different loads on a network so that we can provide consumers with better information about what in their home or their business is actually using the majority of energy. We also do things around network management and security for network operators to maintain a high level of availability and optimal network structures. We also do something that we call demand-side management. And this is the one that I'd like to highlight today. Demand-side management is basically the principle is that throughout the day, the energy consumption curve increases as people go to work and start using energy in business, and then it shifts, load shifts as the workday ends and people go home. Most of the time during the summer, especially in hot places like California, the demand curve increases rapidly during the day as air conditioners come on. And in some cases, that can cause too much strain on the network, on the distribution network, which requires utilities to either buy energy on the open market and pull more energy into their system, or to turn on what they call peaker plants. Both options are very expensive, but they're both necessary to avoid those rolling blackouts that sometimes happen when load isn't managed appropriately. So what we try to do with demand-side management is we say, let's try and shed some load from the grid during high demand. So first of all, we have to predict, and this goes back to the model that Mike is talking about earlier. First, you have to predict, and then when you detect that there's a situation that requires a load shed event, we leverage the Silver Spring network technology to go ahead and send a signal out to participating consumers who've opted into a plan that allows us or allows the utility to take some control over the thermostat or pool pumps, other high energy draw appliances, and then in order to shed some load. Now, this is obviously not something that the utility wants to do too frequently because it can be disruptive, and these programs are best suited when they're when they're the least invasive. So you don't want to be sending these signals too frequently, and when you do send them, you want to make sure that you're sending them to enough consumers that actually it's taken effect. And this is where the streaming analytics comes in. So now we've sent a signal, we've tried to curtail some load. Now we want to actually measure in real time to figure out how much load we've actually shed, and if we need to go ahead and shed more, or if we can back off on the program a little bit, just so that we can impact the fewest number of folks as possible. So I pretty much talked through this slide already, but the way that this happens is immediately after sending a load shed event to the meters, this triggers the meters to start streaming data in real time back to our real-time stream processing, and the data torrent process actually enriches those streams with metadata so that it's contextualized. We know where the event is having the most effect. We know where the event is not having the most effect. We can also have a rolling summation across different areas, across the total service territory, and we can also look at the variance in real time so that we can see really what the effect is of the load shed event. And then we make those results available to the utility via an OpenADR API, where they can do a comparison about what the effect of the event was versus what they expected it to be. And they can also apply some machine learning capabilities to it so that the next time they can make more accurate predictions and also make more accurate load shed signals to the network. I think with that, I'm going to turn it over to Himanshu.
Great. Thank you very much, Jeremy. Hello, everybody. My name is Himanshu Bari. I am Director of Product at DataTorrent. And for the rest of the webinar today, I'm going to discuss, I'm going to build on what Mike and Jeremy said and really discuss how you can truly accomplish building a platform that can be the one platform for batch and stream processing. Before we do that, just real quick about DataTorrent. So DataTorrent was founded about 3 years ago in 2012 by Fu and Amol, who were execs at Yahoo, and the core engineering team came from Yahoo Finance, and they brought all their experience in using Hadoop and building a real-time stream processing platform for Yahoo Finance into our core product. And we really started out with a unified, simple mission of using this technology to help our customers get faster time to insight, reduce the time it takes for them to take actions at the right time, and generate greater business value. And I'm going to discuss how, as we started, though we started at the point where we looked at a lot of streaming use cases, we quickly converged to bringing our platform to be the one unified platform for both streaming and batch use cases. Before we do that, just a quick refresher on what a typical stream processing data pipeline looks like. And it usually starts with looking at some of your streaming data sources, be it Kafka, JMS, or what have you, and doing simple normalization and transformation on that data before you can then apply your rules, look at certain thresholds, run models, and take actions at the right time and do real-time data visualization. And this has been a repeating pattern that we've seen across customers as we've implemented a variety of stream data processing pipelines. But then we also started having discussions with our customers around batch processing. And the pipeline you see below is a typical standard batch process where you start with some static data, you do a lot of extraction, transformation of the data, you load the data in a variety of different data sources, and after it's been transformed and loaded in the right data repositories, then you do offline analytics, and you then, based on that, take actions. But what we found from some of our implementations is that if you would take this pipeline and implement that over a stream processing platform, everything pretty much stays the same, but you can actually get your insights and take actions much, much faster in the entire pipeline. And now if you look at these two pipelines, they end up looking similar. And that's the point, that the only thing that is changing between these two pipelines is whether your data is at rest or whether it's streaming data. The processing logic should pretty much be interchangeable. As we speak to customers, the discussion often starts with, the customers needing help with figuring out what the right use cases are for stream processing. And the best way we found is to start the discussion by looking at your existing traditional batch processes. And what we see is that as we start peeling the layers of the onion, the use cases often start clarifying into two buckets. One is the existing monolithic batch that can be made faster. And these are your fast batch use cases. And these are some of the use cases that perhaps will never move on to streaming because there is just various different factors around when you actually get hold of the data. Jeremy was talking about how they have to deal with various legacy processes to get hold of some of the data. And it's true across all the verticals. So there are often third parties involved. You just cannot get to the data as it's being generated. So for some of these processes have to happen in a batch way. There are also a variety of different use cases around historical analysis, doing data reconciliation, running audits on historical data, generating over your machine learning models by looking at all of your historical data, and these have to stay as batch processes. But then there are a lot of different use cases where from the traditional batch that can extract and do it in a streaming fashion, because you can go close to where the event was being generated. So you can look at some of your clickstream logs as they were being generated. You can do real-time KPI dashboards based on that information. You can run some of your machine learning models in streaming mode and get your insights faster. Between these two pipelines, you will often find there is a lot of sharing going on. There will be a lot of logic that is common. Let's say you are generating a dashboard over last 5 minutes worth of data. To test that dashboard, perhaps you want to run it over a bulk of historical data. The logic doesn't change. All that changes is the data. There is a lot of sharing between your batch processes and your stream processes. The models and thresholds that you will often employ in your stream processing pipeline to take actions are often computed offline based on a whole lot of historical data. So you need to have an easy way of sharing those models and thresholds between your batch pipeline and your stream processing pipeline. And the same applies in the other direction as well. As your stream processing pipeline is running and taking decisions based on your fresh data, you want to feed that fresh data back into your batch processing pipelines so you can update some of those models and thresholds. So net-net, what you would see is what you need to get to is you need to get to this blue box that says that you have one platform where you can define your streaming-only pipelines or your batch-only pipelines or your dual streaming and batch data processing pipelines. And then based upon the use case, you can just point that pipeline to stale data or to change data, to your fresh streaming data or your transactional data without having to make a bulk of code changes, without having to migrate the pipeline from one platform to another, without having to go through all the operational headaches. And that's exactly what we here at DataTorrent, we provide to our customers. I'm going to next cover the variety of different aspects of our platform and give you a flavor of what they mean through the lens of providing a unified batch and stream processing engine. So at the base, you have your Hadoop cluster. The DataTorrent core is Apache Apex. We recently released it to open source. It's incubating in Apache right now. And it runs over any Hadoop cluster. We are certified with all major distros. We run in the cloud or in a physical or a virtual environment, and we have customers running us in all the environments. On top of the core, we have our operator library, which is also open source. It's called Apache Malhar. And I'll cover some of the details in a second, but that gives you a great starting point where you have a lot of functionality that's available out of the box that you can use to create your data processing pipelines. Now over this library and the engine is now where we have our tools, starting with our centralized management platform to your graphical application assembly tool and also a real-time data visualization tool. And then on top of these tools, we are now launching applications. The first application we launched was a data ingestion application, and you will see us launch more applications around the entire data processing pipeline. All the data that we process and store within the Hadoop cluster is available via our REST APIs for integration with other aspects of your data management platform. Now, I'll spend a few minutes on each of these boxes here, but before I do that, I really wanted to share a very interesting use case that we recently uncovered with one of our customers. And this customer was a satellite television provider, and they had a legacy billing system. And the goal of the billing system was simple, capture all of the package data, the rate rule data, the subscription data, run it, it was based on your traditional relational database with a lot of processing logic written on top of it. And it would produce bills that would go out to customers at the end of the month. Now, what they found was they moved to Hadoop with the goal that their existing billing system was not able to capture all the historical data. So they often had use cases where they would change the rate rules and they wanted to do what-if analysis to see how that would affect the bills that they would send out to customers. And it was very, very hard for them to do that in their legacy system. And their goal was to start using Hadoop for some of that. Audit and reporting was also an important use case. That customer would get audited, not always on a very well-known schedule. They would often get ad hoc audits because their customers would ask them questions and they had to prove why a certain bill was sent out. And this was very hard for them to do on the legacy system because, again, they didn't have all the historical data. They didn't know the exact state of the database when that certain bill was generated. So the whole goal was, let's move to Hadoop so we can solve some of these use cases. And what they found quickly was they started putting together this batch processing pipeline by ingesting all the data into Hadoop using the traditional tools like using Scoop and using file transfer methods, and they started writing a bunch of Hive scripts to put together their data processing pipeline. And they quickly uncovered problems around being able to operationalize this whole pipeline in Hive was a big problem. Plus, they couldn't look for rules and patterns within that entire pipeline. Their end goal was, though they would want to run this pipeline over any granularity of historical data in Hadoop, they wanted to move to a state where they could change a rate rule within a billing cycle and then know what impact it would have on the billing performance. So they wanted to make changes much faster. So though they were starting out with having a faster batch process, the end goal was to take pieces of this process and actually run it in a streaming mode by connecting the pipeline directly to their transactional systems to streaming data. They took this pipeline that was written on top of Hive and ported that pipeline on top of DataTorrent, because now they have a unified platform where they have a faster batch process where they are calculating their bills based on a bunch of historical data, so they can do ad hoc auditing and even do what-if analysis on historical data. But now they can take the same pipeline and connect it directly to their source transactional systems, their relational database systems on streaming data, and take actions within the billing cycle as well. All right, so now let's move on to covering the different pieces of our platform in a little bit more detail. So Apache Apex is the name of the open source project, the core DataTorrent engine that we released to open source a couple months ago. And the key features, I will get to that in a second, but I encourage all of you to please check out the incubation website. The link to that website is at the bottom of the slide. So what makes Apache Apex different than other options? And I always like to answer that question with posing a question back to customers saying, you know, it's very easy to look at a stream processing or a batch processing platform and everything runs fine. What you got to look for is how the platform reacts when something breaks. And that's exactly what Apache Apex capitalizes on. So there are a bunch of different points on this slide. I'm going to touch on them one by one quickly to point out how we truly help you to build that unified platform and take away all the operational headaches around building that unified platform. So, you know, like Mike mentioned early on in the presentation, we are an in-memory compute engine, and that's pretty much a prerequisite to building a platform of this nature. But then we are also Hadoop native, and by that what we mean is that, you know, we run natively within the Yarn cluster, and we don't have our own scheduler. So we don't have any of the multi-tenancy issues because we truly and completely rely on Yarn for all scheduling and resource allocation. We also use HDFS natively for all the state management within the platform. So the developer doesn't have to worry about using any sort of an external data store like a database to keep track of intermediate data and intermediate state. It's done transparently for them using HDFS. We can do sub-second event processing. So for us, we have a unique way of processing events where no matter what processing guarantee you need, we can still provide sub-second latencies. We have customers running us in production where they're able to get latencies in milliseconds. And we do that while, like I said, while providing all three event processing guarantees, exactly once, at least once, and at most once. So as we've seen customers embark on their journey of implementing their fast batch and stream processing on our stream processing pipelines on our platform, we often see them facing this problem where when these pipelines run in production, there are oftentimes queues in the input data. because there is a lot of seasonality, there is intraday variations, and it's very hard to design a platform that will automatically adjust to these skews. The platform, it's very hard for the user to put in controls to manage these skews. This should solely be the platform's responsibility. And that's what we have built into Apache Apex. What Apache Apex has sophisticated stream partitioning and unification mechanisms, so it can easily automatically partition your pipeline to manage the data skews. And you can do that by simply configuring a throughput and latency SLAs, and the platform will take care of automatically parallelizing the operators or reducing the parallelization of the operator to meet your throughput and latency SLAs. I said earlier on this slide that what differentiates one platform from the other is how it reacts when something breaks. The stateful fault tolerance is a very key differentiator for Apache Apex. We do that by doing continuous checkpointing of the entire application state into HDFS without needing any intervention from the user or the application. And this allows us to quickly recover upon failures to the previous well-known state without having to go back to the source all the time to get back the data. And we do the recovery in an automatic and incremental fashion. Like I said, you don't have to go back to the source to get the data upon failures. We have support for rolling and tumbling windows as well. So oftentimes when you run your analytics, you want to do the analytics over a sliding window of, let's say, the last 5 minutes, or you want to do the aggregations and analytics over a tumbling window where after every 5 minutes you start aggregating the data again. Now, the user doesn't have to code any of this logic in the application. It's supported out of the box in the platform. And the last part is, as you run these applications in production, oftentimes we've seen use cases where people need to update some of these thresholds. For example, your machine learning models might need to be updated very frequently through the day. In our platform, you don't have to bring down the entire topology to do these updates. You can do runtime updates to the application without needing to bring down the entire application. A quick summary of what we have in our Malhar operator library. So Malhar has a whole lot of input-output connectors. The main goal has been that we want to have you to have an easy way to connect to any of your existing data source and destination systems. So be it a file system, your relational databases, your NoSQL databases, your search systems, regular FTP or protocol. We have a whole bunch of connectors to connect to most of these. We have a lot of compute operators for doing things like pattern matching, statistics, algorithms. We have a bunch of parsers for doing some parsing of CSV, JSON, and so on. And the main point here is that the API is very simple, so you can implement your own operators as well. And one recurring theme that we've seen from our customers is they're able to plug in their existing business logic in our operators. So unlike having to use an API like MapReduce, where you have to rewrite your existing business logic in MapReduce, you don't have to do that in our platform. You can take your existing business logic and plug that right into our operator, so you can get your application done faster and get to production faster. So I'm going to skip through some of these slides real quick. I'll give you some flavor of the rest of our platform. So we recently launched a graphical application assembly tool called DT Assemble. The goal here is you shouldn't have to hit a code editor to write your first streaming or batch processing application. So this UI gives you a drag and drop way where you have access to all the operator library. You can drag and drop these onto a canvas and simply connect them and launch the application right from the UI. And this tool doesn't have any external dependencies. It's just part of our platform. You don't have to install any database or anything of that nature. We also launched a real-time data visualization dashboard. So, oftentimes as you put together your stream processing pipeline, you want to get to know the results of that pipeline sooner. So we integrate with any of your BI tools, but if you want to see exactly what's going on in that application in the last 1 minute or the last 5 minutes, you can use our real-time data visualization dashboard to get that visibility. we have a bunch of different types of charts, the commonly available bar chart, line chart, pie chart, and you can even define your own custom data sources within the application to connect to this real-time data visualization dashboard. And lastly, we launched a data ingestion application, and this is an app that we're seeing great traction with from our customers. And the goal of this application in the first phase has truly been helping customers put away tools like DiskCP or manual file transfer that they're using to move files into the Hadoop cluster. This application gives you a simple point-and-click interface where you can choose your sources, whether it be file-based sources or message-based sources like Kafka or JMS or Amazon S3, and configure various parameters like whether you want to compress or encrypt the data on the fly, and then pick your output destination. The output destination can be a Hadoop cluster, or you can choose to send the data from the Hadoop cluster to any streaming or file-based source. It's a simple point-and-click interface, and we take care of launching all the application behind the entire application behind the scene and operationalizing the application and running it at scale. You as a user have a very simple interface to create and launch your data ingestion pipelines. So hopefully that gives you some flavor of why a unified stream and batch processing pipeline is important. And you saw some examples of how many of our customers are moving to a unified batch and stream processing platform. But the key is you need a unified platform that runs natively in the Hadoop cluster that takes care of all the fault tolerance and operational headaches out of the box to make sure that you can truly create these unified pipelines. So at this point, I will stop, and if there are any questions, please type them into the chat window, and I'm happy to answer questions.
All right, thank you very much. We know we're close to the bottom of the hour, but we have a few questions in the chat window that we can address really quickly. And those which we don't get to, of course, we will be able to blog about for you. All right, the first one I believe is directed for Jeremy. The question is, the Silver Spring Network example is very interesting. Could the speaker discuss the deployment process for DataTorrent? Was it difficult to implement? Jeremy?
Sure. I think that this was one of the reasons that we selected DataTorrent as our vendor. I wouldn't say that it was necessarily easy, but we got great support from the DataTorrent team. They came out and trained our engineers, and they've been very responsive to our issues. I think the trick with it for us was just learning this new paradigm, which didn't actually take that long. And what we saw was once we had a couple of DAGs deployed, we were able to really accelerate that development. And I couldn't be any more pleased with how easy it was to deploy, and also the support that we got. But more than that, just the rapid development uplift that we got from our engineers.
All right, great. Thank you so much. The next question, I believe, is directed for Mike. So the question is this reality? Are companies really using a single platform for batch and streaming? Mike? What's your take?
Yes, I would say it's a reality, but it's new. So many firms have invested a lot of money in sort of those offline analytical workloads, and when you think of Hadoop, that's what people think of. They think of, okay, we're going to do all these batch processing jobs. So firms are doing it, but it is new, and I think there's an opportunity to move a lot of those analytics that happen in a batch mode into the streaming pipeline.
All right, great. Thank you, Mike. All right, our third question, I believe, is going to be directed more at Himanshu. The DataTorrent ingestion application looks very interesting. Is it ready now? What if I add, sorry, I'm just looking at the question here in the pane, to the update the full DataTorrent product.
Great. So let me make sure I got the question right. So I think the question was, the ingestion application looks great, it's available now, and what if I want to, from what I caught, what if I want to add something to the ingestion pipeline and kind of customize it? So yes, absolutely. So let me throw a little bit more color on what our goal with the ingestion application is. Today it's going to allow you to add, take any of your file data or streaming data and ingest it into a bunch of different data destinations like HDFS. You can send data to Kafka, to JMS, and so on. But that's only the first step. We see a lot of customers who are just struggling with just simply getting the data into their Hadoop cluster. And that was the problem that we're looking to solve with the first phase of the ingestion application. And you will see us launching new versions of the next version of the ingestion application where you can then truly customize the ingestion pipeline, where there will be a lot of out-of-the-box customization capabilities available, where that you can configure to make the ingestion pipeline your own. And I want to make a point that the ingestion application is something that just works and runs out of the box, but all the operators and capabilities that the application is using or was built on are available as part of Malhar. So we are working with a bunch of our customers today where they are taking these operators and building their own custom ingestion pipelines as well. So you have both options: either use our ingestion application out of the box or also build a custom ingestion pipeline.
Great, thank you so much. All right, since we're at the bottom of the hour, we're going to go ahead and wrap the webinar up. Thank you once again for joining the Faster Time to Insight and Action with Unified Batch and Stream Analytics webinar. Huge thanks goes to all of our great panelists. And for those who joined, please see datatorrent.com for more information regarding data torrents. And as a reminder, this webinar has been recorded